Hey everybody. Welcome to Not My Usual Background. So doing a live stream, of course, here, I guess before quiz 3. If you have questions in the wherever the chat is, as usual, in the YouTube chat, I don't have Piazza open. So I don't know. I mean, there's not many of you. Maybe your houses are also out of power. I lost power at home at like 9:30 this morning, and luckily had the presence of mind to get up here with my second tier streaming setup. A GoPro. I usually stream. I'm usually through an SLR. I'm streaming through a GoPro on a HDMI capture, like a caveman. And I hopefully, like, everything okay, like audio okay, all that. Who knows? Anyway, yeah, luckily power's back on campus. Am I early, really? Oh, I am. Why is my computer clock is for some reason not synced. That's weird. My computer clock is like 4 minutes fast. Oh well, I'll just kill time then until 11:30. Yeah, you do the jokes, guys. This can be your job. Okay, there we go. So I don't know. I mean, I guess my my computer would have my office computer would have rebooted yesterday. I don't know. Maybe I lost my time sync there somehow or there. Yeah, like being 18. The power outage on campus yesterday was like weirdly long. Yeah, you know, like I said, I hate extending an assignment. I really do for some reason. See, the problem with my keyboard is I'm also on my second tier microphone. It's just a little bit closer to my keyboard. I'll try to keep that under control. I could change noise filters maybe. Can I do that live? Oh no, I can't. I can't because I'm a version back on OBS here. I don't have the new noise filtering. Anyway, yeah. It's weird. Like, it's weird being in my office. It's weird. By the way, like, for those who were on campus and lost power yesterday, when was it? It was 20 and a bit years ago. I was in residence at SFU, and the power went out in a very similar way. That's the day I met my wife, because we were hanging around in the common room because nobody else had anything to do. So I'm partial to power failures on campus. All right, so, okay, it is actually 11:30 now. Hi, everybody. I started early because of a clock sync problem. I don't know how many people are here. There we go. 8. I'm wondering if perhaps others are also having power problems and will be watching this later because they're sitting at home with no power. Anyway, as usual with these live streams, I guess we're presumably talking about quiz 3. I know, like, again, the subtleties of the timing were you were supposed to finish assignment 3 definitely last night and then be thinking about the quiz by today, and it was all going to be beautiful. And now, of course, a lot of you are thinking about the quiz again, thinking about the assignment still. So, yeah, try to focus on the quiz. I mean, if you have assignment questions, I can try to answer them, but I think realistically, this is not the forum for that. Piazza is much better. I'm also getting, like, it's like, the GoPro is, my HDMI capture is like 10 frames per second. I'm not happy about that. Look at that. Unacceptable. So, I do see people trickling in now. So, what do you want to talk about? I assume it's quiz 3, which is covering Go and concurrency and stuff. And I have no ability. I'm not going to tell you what the questions are because I've totally forgotten. Like, it's about half made up, And by virtue of running up here this morning with a backpack full of AV gear, I've completely forgotten what I put on the quiz. Really more with Go than with Haskell. Interesting. Like in some ways, Go is a normal programming language, right? It's much more like what you're used to. But I guess you know, I have been hitting the concurrency obviously, and that's been again, like especially if you haven't dealt with that before. And I think you had said you hadn't, like if you haven't taken 300, yeah. Is the quiz only on Go? Yeah, the quiz is on whatever I said. Basically, well, not quite. Okay, let's come to here. So certainly the Go stuff, not the Prolog stuff, but I guess this last, like I don't have a lot of really functional stuff to ask you in this sort of conclusion topic, but I guess in theory I could. As usual, my default plan here is to kind of go through this section of the course with a little bit of review and a little bit of like color commentary. Anybody got any better ideas? Yeah, you know, Cole, like I've heard this thing like, oh, you can use Go modules. But again, I just keep typing the command and I keep getting told to set my Go path, which I have done, by the way. Again, I'm on a different computer, which is very disorienting. You know, I have an account on my main computer set up for lectures and stuff. Now, all of a sudden, I just don't have the font size and everything. I had to set up OBS. All right. So, oh, and by the way, I have heard of GoPros overheating in scenarios like this. It is a touch warm in my office when they're running hard. So if my video drops, that's why. The audio and stream should be fine. Campus network connections tend to be pretty good. Okay, so yes, modules are easier, and yeah, 5 hours later, they're not easier. I believe that. Okay, so again, like as far as I'm concerned, like the basics of Go are pretty basic, right? It's like C, but with slightly more modern syntax, maybe. I think the really interesting thing about it is concurrency, because yeah, we all have multi-core processors all over the place. We want to use them for stuff. So yeah, the language basics, I think, well, once you get by like, you know, this slide, right? These getting paths set and whatnot. It's a programming language. It's imperative. It's got variables and loops and things that you kind of want in a programming language. The capital letters are exported. This is something that caught a few people out. I noticed on like later exercises where you forgot this thing. Yeah, like the case of the first letter in an identifier name has this really big meaning that's kind of staring you in the face every time you touch it, which is a little odd, I find, but there you go. I don't know. Variables are what they are. The type inference is interesting. I think we've seen. There is, I guess, something I don't think I've said explicitly, but definitely has been there. There's kind of a limit on what can be type inferred this way, right? If Go sees something with a decimal, then it maps to a float 64. If it sees an integer-like thing, it maps to an int. If you want to say something like this, did I have an editor open? I did. If you want to initialize something to a uint, and I suspect some of you may have had to do this, you end up doing that. Where it's, I mean, I guess technically that's a conversion function. By the way, font size okay here. I had to change it, of course. Not my normal editor font size. Oh, an alias for the command. That's a good idea. So yeah, I guess, I mean, this is technically a conversion. I would guess maybe the compiler makes it go away and it's almost like a type annotation or something, but it's odd to have to do that in order to basically please the type inference. And then there's the alternate version of that, that is d the uint is a new variable that gets initialized to that. So those are, of course, equivalent. Okay. Functions are functions, and the arguments are explicitly typed, right? So argument type, return type, we've seen that enough. I don't think it needs much more. There's a little bit of like color in the return types. You can have more than one of them, and they can be named, as we saw. If they're named, you get that variable, like local variable created for free. Which is funny. And then I feel a little bad, like, I don't know if I covered defer at the right moment. Like, defer is about exiting a function, so I kind of covered it when I started talking about functions. But it's also kind of about error handling. And I guess you've sort of seen it in both. So we saw the defer as like, if you're managing a wait group, I want, like, no matter how I get out of this go routine, I want to make sure I decrement the counter in my wait group. So saying defer that dot, whatever the method is, dot finish or something. That's a really handy thing to do in a defer, just so you don't have to worry about it. You know it's going to happen. And also for error handling, this kind of thing of, look, if some crazy error happens or I have an early return, whatever, I don't care, but I do want to close the file as I leave. If statements work like if statements, loops work like loops. And this is one thing, and I said this during lecture, right? The C style for loop gives me hives. It's just not, hate it. But you can do it. Probably much more likely in most Go, most of the time, you're going to write the for range loop. But, sometimes you end up just having a count. The simplified sort of loop, the like minimalist guide to looping has been interesting, where, okay, if you do have the C style for loop, you can selectively remove parts and invent a while loop. Or invent an infinite loop, as long as that's, the sort of logic you want. Okay, so structs in Go are, again, a little bit interesting. And I guess they're interesting because they're a little bit like a struct as you might know it from C, and they're a little bit like a class as you might know it from C++ or whatever other object-oriented language you're thinking of. So the basics are, they're a struct, and you can have methods. So we saw this receiver argument that's like this or self in Python, or sorry, this in some languages, self in Python. It's what's the thing I'm attached to as a method, and so you can modify that. And you can work with that. Modifying it is a different thing that we'll come back to. And by the way, what do I got? Oh, people have arrived since I started talking there. Welcome everybody, if you're just coming in. But as always, if you have questions in the chat, and I'll keep an eye on it. And otherwise, I'll just keep talking for a little while. So I'd be curious to know if this was annoying, right? So certainly when it came to the exercises and assignments, there were situations where you had an int and you needed an unsigned int or vice versa, something like that. And that you have to do this conversion every damn time. You have to do everything. Any votes? Like, did you like it? Did you hate it? I weirdly like it. And I think I'd hate it if I wrote Go every day. Like, I like it as someone who teaches programming languages. It's like, oh, cool. Like, this conversion was always happening. And by the way, and I've heard a few people say, like, oh, we have to convert, as if that's like you're introducing an inefficiency or something. like this conversion always happened. Like if you write the analogous code in C, which I guess would be this, the conversion still has to happen. It's just the language does it for you. Oh, new variable. So you created a variable and initialized it and kind of did the conversion as part of the initialization. Interesting. That's not a bad idea. And yeah, I agree. Better than JavaScript's implicit conversion. Oh God. See, I'm out of control of my lighting. So at home I have like I have a ring light and a main light and a fill light, and now it's just the sun and clouds. It's madness. Anyway. So yeah, like this is explicit as opposed to something that's implicit in most languages. Like again, C, you could do that analogous thing. It's just the compiler effectively inserts one of the conversions for you, and it knows which one. Oh yeah, converting. Yeah, I agree, Sean. Converting an uint64 to a uint is a flaming pain in the butt because come on. But yeah, very explicit in Go. Right, arrays and slices. It's a funny distinction that, again, I don't know of in any other language where an array is effectively an allocation. Like in some ways, creating an array is equivalent to allocating memory, like you doing a malloc or malloc, however one pronounces it, in C, or doing a new something or other in C++. And then, but working with the data type, well, the data type you work with is probably a slice that refers to that underlying memory allocation. Again, it's a funny distinction, and you can like it or hate it, but there you go. Right, so we saw the range over, so I guess this was the first 4 range that we saw, ranging over a slice, or I suspect you can do an array as well. So position comma value, which would be like enumerating a list if you're a Python programmer to get both position and the value at that position all at once. And probably not this, right? You probably shouldn't be explicitly doing this most of the time because mostly you will hopefully let the for range take care of it all for you. Yeah, so, oh, interesting. So yeah, in assignment 3, where you're creating the string that gets hashed, that's a more explicit conversion, right? Like converting an integer to a string, well, I guess, again, like if you have, I forget what the things are off the top of my head, but if you have the like, in some languages, you could do the equivalent of, what is it? The like difficulty or whatever. So this is always a funny one for me. If you start doing string arithmetic, but with non-string things and the conversion is automatic, see, that's one, it's exactly the same as the other case, except this one freaks me out a little bit. This one, I think I should have to explicitly convert. And yeah, you could have done, you can do it with some string arithmetic or sprintf to create a string from a format string. Yeah, either one of those is fine. Where was I? Yeah, slices and stuff. This is one, okay, so like creating the slice dynamically is, yeah, a little bit different. And this is, again, different from, I guess, notably C, where things are initialized to 0. Every type has a default value. It's 0 for any numeric types or empty string or empty list. But everything gets initialized. There's no concept of like, just give me that memory and whatever's already sitting there, I'll use it. Yeah. Okay, so those were the Go basics. And then we entered the concurrency part. And again, I think this is, I think, the interesting part about Go. Certainly if you're, like I think most programmers should do more concurrency more. And again, I think my assertion is that the craziness that is concurrency in the most general case, like in Compute 300, is important, but maybe not everything usually it's easier than that. Okay, so we saw these Go routines that are relatively cheap. They're user threads, or user space threads, or however we say that. Yeah, I agree. I'm with you, Nicole. I also forget that initialization happens. Right. So yeah, we have these lightweight threads that we can create very easily, like very easily in like the system sense. They're cheaper, and very easily in the programming language sense, where we just say, oh, go function call, and then a thread happens. Which then, of course, has all the good and all the bad of threads, where you have, well, you shouldn't be sharing data structures between them. You have, if you want to coordinate, you need some kind of support for that. But hey, it's easy to do something concurrently. And again, in the easy case, if the and I guess I talked to somebody who was doing something like this for the project, I think, where they were writing a server-like thing in Go. Well, then it's super easy to use concurrency. If you have a like respond to a request function, then you just have a main loop that's like, well, wait for a request to come in. When one comes in, call the respond to request function in a Go routine, pass it the request, have it do what it does. And then if 1,000 requests come in per second, well, you use all your CPU cores and off you go. That's the kind of use case that I think things are designed for. So when communicating becomes a thing, we end up with channels. And I think you've got a fair bit of experience with channels by now. Fundamentally, there's these, well, they carry a type. There's these two things you can do with them, send and receive. I've always been annoyed that, like, I wish this was easier. I wish it was easier to convert a non-channel-ish function like this into a channel-ish function like this, right? Like, we've done this so many times, like pass a channel as an argument, and then instead of returning, send the result. Like, I wish there was some decorator I could put on a function or something that says, well, actually, you know, there'll be a channel and return into the channel instead. But you end up having to modify your code and do it manually. Which was maybe the most annoying in the like Fibonacci code you wrote in the exercise. Where that was like you had to write this completely different function that did the same thing, or like depending how you approached it. So yeah, these first examples, I kind of deliberately avoided a bunch of stuff. Like I avoided anything that would need wait groups, where I would have to keep track of am I done or not, or like I want to. How do I know that all my Go routines are finished? And I've just, all of these examples were chosen to really sidestep that, where I know exactly how many things are going to get returned. And so I can kind of plan for that. Right, so we saw this construct. So another thing that we can range over, a channel as well as a slice or array. If we're ranging over a channel, it has to get closed. So whoever's sending into the channel has to close it. This is going to be a thing if you've got more than one sender, right? So if I, you know, whatever scenario I have here, if I'm going to start up 2 of these and I want to receive all of them, then kind of whoever's last has to close the channel, and that's not easy. You're not allowed to close a channel more than once, and of course, if one of my Go routines finishes first, I don't want it to close the channel because the other one is still working. So again, somebody asked a question in Piazza that I think they were trying to approach things in a much too complicated way, but it was, well, can I create a bunch of Go routines and another Go routine that watches the wait group or waits on the wait group and then closes when everybody is done? That's definitely possible, not necessary for whatever the problem at hand was, but it's a thing we can do. And by the way, you can close a channel, like in general, you can just close a channel if you're done with it. It's sort of usual Go style to not. to only close a channel if you're using it in this context where somebody is expecting the signal that we're done now. So we saw that channels could be buffered. So you can give the second argument to the make function, and that is, where to put the guarantee? So, oh yeah, cool. So yeah, if you're doing, again, something like a server in Go, I don't know, maybe you were the one that asked this, I don't remember anymore. But it would be something like, in some, pseudocode here, assuming that all you need to know is that request, then it would be something like for something. It's probably maybe it's an infinite loop. And so hopefully you have some concept here. There's some library that is listening on a port, and whenever a request comes in, it hands it off to you. So maybe this would be something like something that you have gotten, like handed to you. I suspect it would end up being something like that, where again, every time a request comes in, start a Go routine to handle it, and assume that somewhere down here, okay. So, proposal in the chat is that it would look more like this, and that this would then block until a new request came in. Yeah, give or take your library. Yeah, you're going to end up looking something like that. And again, this is beautiful, right? So you're already going to write this function, right? You're already going to have code that does this work. Take a request, generate a response, and it's just so like you could do everything single-threaded, or you could make it all happen concurrently, and it's just that easy if sort of everything is set up to work, and that's really cool. All right, channels and buffers. Right, so the buffer channel if you need it. If you need, if you want your threads to kind of, one can get ahead of the other a little bit, because otherwise, and maybe I didn't say this, but if you have a non-buffer channel, you sort of have to hit this line and this line, the two threads have to almost synchronize at that point, right? The one who's trying to send has to wait until somebody is ready to receive, and the one waiting to receive has to wait for somebody to send. So the two threads have to come to that moment kind of together. You don't know which one's going to go next or whatever, but that's maybe bad, right? If you're trying to get a whole bunch of compute work done here and you want to get on to the next step so you can get it moving, maybe a little bit of buffer will allow that to happen. I don't know if we used a channel select anywhere in this, did we? I guess depending how you approach something, maybe. But again, got a bunch of channels. I want to receive from whichever one has a message first. And I don't know if they all have messages. I don't know which one. Maybe this one goes, maybe it's in order, but I have no idea. But the idea here is a whole bunch of things are going to be producing messages on a bunch of channels. I want to deal with them as they arrive. Okay. So that was the basics of concurrency, enough to kind of get things rolling. And then, so I talked a little about structs, a little about Go routines, and then more about structs and more about Go routines. So was the sort of layout there. As we come back to structs, okay, pointers work. And yeah, there was something in here. I said something that in the lecture, and somebody said in the chat, I don't think that's how C works, man. And I was like, yeah, okay. I don't write a lot of C. Whatever weird thing it was that I said, just ignore me if I say something wrong. But it was about a language we're not using. But anyway, pointers, as pointers should be, and in fact, really, I think as pointers should be, right? This pointer arithmetic what really causes problems in C a lot of the time. Oh, you can buffer a channel with 3 arguments in make. I don't know. Yeah, I don't know. I don't know what the 3 argument version of make is, to be honest. Am I going to immediately find a reference to it? Okay, so I can give, so you make a type and then the size, but that is presumably any number of those. This slice, okay, so it depends on the type you're creating, and I don't know, whatever it says in the docs there. Second, capacity of the slice is equal to its length. Oh, okay, so this, for a slice, it's a question of like, how much memory do I allocate versus how big is the thing right now? So if you need a small array now, but you're going to expand it later, you can say, you can give another size and say how much memory to allocate versus how big is the thing at the moment. And it looks like it doesn't apply to channels. There, I did it. Okay, so we end up with this situation where pointers let us follow pointers. So if you want to give somebody a reference to something in memory, you can get the reference, give it to them, and then they can follow the reference and actually change the underlying thing, which again is like C and C++. So sometimes you have to know that, sometimes you don't. All right, pointers to structs, and again, we see how this, like, there's a slightly leaky abstraction there. It looks like the pointer means you can modify except these other footnotes that you can if you want to have a reference-ish thing and modify. But again, I think mostly, yeah, this is another one of these Go features that I'm really mixed on. That I can say pointer dot method, or I can say follow the pointer dot method, and they mean the same thing. Well, when I'm calling a method like that, but kind of only in that case, or calling a method or accessing some other member, like I could say dot length or something. It's just so, it's convenient, and then all of a sudden it's not convenient anymore when the language decides that those aren't equivalent statements to sort of say this thing or this thing. I can't believe I like a C thing better, right? But in C you can say like PTR arrow member, right? If you want to follow a pointer and then access a thing, maybe I like that better actually. It forces you to deal with what type you have. Okay, so we saw these then footnotes on, again, like this is a lie. Like if you have a pointer you can modify, if you don't have a pointer you can't modify. Well, except when you can follow some other pointer or deal with a reference. I think if you, like, I think this is straightforward enough if you sort of know what's happening in the computer, that if I find a pointer I can follow a pointer, basically. So once again, it's, we don't have references in Go, but except the times we do have references. Slices, it turns out, are effectively references to an array. And slices can be references to other slices if you're sort of sub-slicing. So be it. All right. Type definitions. This is another one where I have gone back and forth on how to introduce this. We saw the typed keyword early on, and it was always this. It was always creating a struct, and then I'm putting methods on it or whatever. It turns out you can equally well do this. So effectively, the struct with the curly braces is just a type, right? So struct curly braces is just a type. as much as float64 as a type. So you can put it in that spot, or you can put float64 in that spot. I'm never sure like maybe I should have introduced this first to say type. The type keyword creates an alias to a type. You can have a nil pointer in Go. In fact, that's the default. So I think I did that somewhere here. Like somewhere here that happened. Where I have... Anyway, if I create one of these structs that I have and I have been playing with here, if count p doesn't get initialized to something, it will be nil. But that will be, if you follow it, you get a, there's no question about that failing. But you definitely can do that. And if you don't initialize that, nil is the default. Okay, so the reason you might want to have this subtype or declared type, I should use the Go term. Maybe it's something like this, where you just want to be a little bit more explicit in your code and say, well, yeah, it's a number, whatever. And like I was writing code not in Go just a few days ago, and I found myself like I have this like tuple of 4 things, and the 4 things are like a string and a integer and a something. But those 2 strings are very different. It's actually, one of them is a name of a host name, and the other one is a status code or something. It feels weird to have those 2 things be the same type when they're holding such very different information. So in that context, I could have done something like this, right? So host name is a string, but it's kind of a special string. And there's the message that's a string, and then my tuple or my data structure would have a much more clear description of what the pieces are, even though it was just like a function returns 3 things, and they are they're string, integer, and something. And again, a bit of a question of style, whether you want to do that or not. And in Go, you can then start like treating it like a subtype or a subclass, where you can start overriding methods and saying, okay, well, if I want the string, so float64 has a default string representation, but this almost subclass of a float64 has a different string representation. So it feels like a subclass in a lot of ways. And you get this really strong type checking that we saw. Again, you saw when you have to kind of regularly convert things. And sometimes that's good, right? You shouldn't do this kind of thing. It doesn't make sense to combine those 2 numbers with a less than sign because they're measuring different things. Take your pick. Okay, interfaces in Go. I guess you have had or are having it today. At worst case, some experience with the interfaces of the runnable thing or worker or whatever it is. For the work queue, that again, like in assignment 3, we created this work queue that's very general, that can sort of do arbitrary work, as long as you don't care who generates the response, or like as long as you want sort of one response and you don't care, if there's 2 responses, you don't care what order they come back, right? We're not keeping track of which input caused which response. It's just responses come out of the work queue if they come. And for our problem, that's good enough. But we did have this interface that is, well, something that can run. Runnable, I think we called it. So the interfaces in Go are implicit. Which I like, and I think some people don't, right? So you don't have to say, what's our example here? The measurement interface. I don't have to look back at this type stock evidence and say, oh yeah, that implements measurement. The compiler can check just fine, right? If I do something in my code and I try to use one of these in a place where I have to have one of these, it can check and say, yeah, are all the methods there? Yeah, they are. Okay, great. Then it's an instance of measurement. I like it. Again, it's a bit of a, explicitness trade-off, I guess, where Go is explicit in its like, you have to be explicit in all of your typecasts. You have to do it yourself. But for this, well, yeah, this one will let it be implicit, and the compiler will just figure out what it should do. It's again, an interesting choice when it comes to the language. And all of a sudden we have much more dynamic kind of typed things in Go, where we can have an array of what feel to me like completely different types and have completely different implementations of that method, and for that matter, of the string method that's implied by that. It feels like that's now dynamic lookup, but here we are. And again, this place where pointer to thing and pointer to thing now, like all the way before, all the way up in my slides there, pointer to thing and the thing itself were behaving exactly the same way. And now, oh, come on, a pointer and the thing, those are totally different types when it comes to implementing an interface. And I think if you're going to, this is an annoyance of mine in Go. If you're going to give me this illusion that thing and pointer to thing are the same, you know, either give it or don't. Don't give it to me, but take it away as soon as I'm doing this other thing. But well, maybe there's probably some really good reason. I certainly don't have the language design experience that the Go creators did. Right. The type assertion is a funny thing where it almost feels like it shouldn't be necessary, except you've had to use one, right? You had to do this with your work queue, because the work queue returns arbitrary things, like whatever that channel is sending. As far as the work queue is concerned, it doesn't care. Whatever the .run method or whatever it's called returns, okay, fine, we'll send it. But then when you get that back, you know that what you got back is a mining result, or again, whatever that value was called, that type was called. So the thing that has the channel or the implementing thing or the method that you called, it doesn't know what the type is, but you do because you're a good programmer that way. And you have to do this type assertion to convince the compiler. There is, by the way, and I didn't mention this in lecture, but I think somebody asked about it or something. You can do, there's a to return value form, like where you can say this. So basically, do the type assertion. If it succeeds, it was okay, and then carry on. If not, if the thing that was in this wasn't actually a pointer to rectangle, this gets set to null or whatever. This is false, and then you would say in here, I don't know what you'd say. Whatever, you deal with that problem. So there is a like guarded version of it where you can check, but I would suspect usually if you're going to use this, you know what's going on. All right. Great. A couple of interfaces that, again, I don't know if we need. Well, you know, kind of implicitly have implemented stringer here and there. You might have, by the way, like you can, like there's nothing to stop you implementing a string method on a block, right? You could say, and maybe it's just that, like you could do that, and you don't need to do it, but you could do it for just debugging, right? If you want to print out a block and see what's going on, this is probably a pretty good representation of it. Just as you're working on the code, you don't have to, but you could have, and thus have implemented the stringer interface, or I guess it's already implemented by some default, but you could override that. We saw the sort interface. When we implemented sorting in exercise N, the merge sort, we assumed more than this, right? We could have said the thing that is taken by the sort method is just an array of sort.interface values. or I guess, sorry, the thing that's taken is a sort.interface value, which we would do as an array of something. We just let it be a slice or whatever. And a slice of something, float 64s, whatever type, just because I wanted to give you a little more freedom than just all I have in the world is these three methods, and that's all I can know about my data type as I try to sort it. But you could have gotten away with that. And I think if you look, maybe the merge would have to be much different if all you can do is swap elements. Actually, yeah, it would have to be very different, because the merge it needs to allocate a new thing. Maybe you can't implement merge sort with this interface, now that I say that, but that's not what I want to talk about right now. And again, you've seen the empty interface come up, and it's the any type you want. Where again, like all of a sudden Go becomes, it was very, very static before, and it becomes more and more dynamic now. Okay. All right, inheritance, and this weird structural inheritance that Go does. Have we used it? No, we haven't really used it, have we? But it's a funny way to do this. And again, we have this illusion that things that are inside an anonymous field are kind of at the top level too. And I bet, again, at some point they're going to steal that away, right? You're going to do something, and then no, yeah, this time you have to do the full explicit descent to the field that you're talking about. All right. Again, I think that's cool. I'd be curious, by the way, now that you've worked a little bit with Go, again, but maybe not this, but do you think this is better or worse? Or is it, I guess, enough? Like, is it good enough to have your programming language have this kind of inheritance-y kind of thing as opposed to explicit subclassing like Go or C++ or something? Okay. Handling errors. I don't know what there's, again, it's important that you see this. It's important that you know this is done. I don't know that I have any, review to do on it. Other than you end up writing this pattern pretty often in the language. Or actually, more realized, you probably didn't write that pattern as often as you should in the language. And I don't either. Because you probably won't fail. It'll probably be fine, you think, when you're writing the code, and that's just not how life works. Okay, but I do want to get on towards this. Right. So yeah, I mean, the better way to handle an error is to yourself do that thing. That your function, if your function has some possibility of failure, it should return a pair. So do I have a function? Well, if I pretend this was going to return a response, right? So if I kind of modify this code and I say it was going to do this, I guess that would be type, something like that, right? So if there's some chance of failure here, and there probably is in this case, I should be returning a pair, and I should be returning a response code and an error, and then doing that. If I'm successful, I return a nil error, and then again, whoever calls it now has that responsibility. And now I haven't actually solved the problem. I've just made it somebody else's problem. It's now the caller's problem. Well, at least I have to look at it, right? With exceptions being thrown in every language but Java, you can write and call the function and not really think about what exceptions it might throw. So Java has checked exceptions where you have to explicitly deal with it or yourself throw it. Okay, I mean, I'll take issue with the word throw in that sentence, but yeah, basically. So yeah, if there's some something that might go wrong here. You would do something like that. Again, assuming sanity, and you know, actual code in here somewhere. Yeah, something like that. All right. Okay, these patterns for concurrency. Again, I think you've had a little more experience with, and of course, this is what I think is maybe most important. Oh, my GoPro hasn't overheated. That's good. Like this is, I think, more important. Like the way that Go handles structs and inheritance is cool and interesting. This is maybe this is the banner feature in Go as far as I'm concerned. I talked about coroutines in the sort of middle part of the course of like, here's something some languages can do and some can't. Go does it with concurrency, like whatever that other, like Kotlin does apparently. If you go around searching for coroutine examples, they're all in Kotlin. That seems to use coroutines as a much more first-class concept, and they're all about making apps because they're in Kotlin. Anyway, because some of us spend time looking for examples of coroutines, non-stupid examples of coroutines that are not just printing "Hello World." Anyway. Right, so this is where we got weight groups, which you had to use in somewhere or other, exercise or something. And this is like the sort of most minimal, you know, concurrency handler sort of tool. It's just a counter, and it's a concurrent counter, or counter that can be accessed concurrently, like in multiple threads. And I can say put, you know, increase and decrease by 1 and wait for 0. That's the entire interface of this struct. But hey, it's good enough. There is, by the way, there's other stuff in the sync package module, whatever we call them. So there are some of these tools, you know, like there's a mutex and a thread safe map, pool of whatever, but I think I'm happy to say, well, wait groups, because this is a pretty common pattern of, I have a bunch of threads, I want to wait for them all to do their thing. What we're doing in assignment 3 is much more like this, right? I mean, different scenario, different interface, etc. But it's more like we have this massive range of possible proof values. We want to kind of effectively map a function over it. Like we want to keep checking proof values until we find one that has some property where some function returns true. So if we started up one Go routine for every proof value, that's way too many Go routines. If we do it sequentially, like the function I gave you that is logically correct but not doesn't meet the spec, it takes too long. So we've broken up the world into whatever number I put in the code, because I pressed 4 digits. Didn't you have to use weight groups? I was sure you did. Maybe you didn't. Maybe you did an exercise question wrong. I thought I had made an exercise question where you had to, but if not, that's fine. Maybe I'm lying. So, right, effectively, this is the style of thing we're doing in assignment 3, which is breaking the world up into some number of chunks with enough concurrency searching the chunks. And then the extra thing that's kind of not in this code is when we find something, we bail. So for that logic, or for this problem, we just need to find one value where we have the right property. We don't have to find them all. So as soon as we find one, we want to bail out, shut down our work queue, and stop doing calculations. Or merge, did I make you do quicksort? Oh, maybe I made you write quicksort and I wrote merge sort, whatever. This seemed to distress people. Like this is, again, somewhat similar to what you had to do with the Fibonacci thing, where sometimes you do it in a Go routine, sometimes you can just do it sequentially. This okay, sorry for panicking, you guys. Okay, you did not have to use a weight group in an exercise. I have good faith in the wisdom of the crowd here. I understand. Well, okay, next semester, next time I teach the course, note to self, figure out something that needs a weight group. Okay, so yeah. I am glad. Like, I'm glad that I am doing Go in this course. I think, like I've said many times, concurrency is important. You have to know how to do it. You need to. The one thing that you really, really need to care about is like, how many threads am I creating? I have to keep that. There's no perfect number, but the right number is somewhere between like the number of CPU cores I have, or the number of threads my CPU can run concurrently, which is usually double that, and like 1,000 or 2. Like, it's a big range, but you have to hit the range of plausible number of threads one way or another with your logic. You're almost done. Actually, you're probably okay. So Prolog is cool. I love Prolog, and also I hate Prolog, and I'm gonna let it go. So I've said not going to quiz, or not going to talk about it on the quiz. So I will not review it. This sort of epilogue chapter in the course is, you know, again, a little bit of like context for me, I guess, of like, here's another aspect of the language choice thing that might come up. So there's a bunch of domain-specific languages that maybe they're programming languages, maybe they're not, maybe you like them, maybe you don't, maybe you've used them, maybe you haven't, but they're out there. So, I mean, I guess I know for sure that, you know, a bunch of you have used YAML for like a docker config.yaml file. You've had to look at that. Many of you, of course, would have written SQL queries. Some of you would have written chef recipes that are Ruby. There's this domain-specific language that does the same thing, like the same job. And again, I would like to contrast the special purpose tool with the special purpose like coding style. Again, if anybody has written, well, again, if you've written a chef recipe, you're coding in Ruby. Like, what you are writing in the default.rb in a chef recipe is Ruby code. You're just not using all of the language. You're doing this very specific thing where you're just specifying configuration steps. Or again, if you're in data science, you've written code where almost everything you do, like almost every line of code, is interacting with Pandas API somehow. It's still just Python. You still could have, you could read a file, or you could have a loop or initialize a variable, like all those normal programming things you can still do, but you're almost always using this library. So, oh, you know what? When did I mention this? Somewhere I mentioned the Matt Godbolt, CPPCon talk from last year. I will post that in Piazza. It's the godbolt.org guy. But he's talking about modern C++, and he implements like ray tracing or something using like object-oriented style, data-driven style, which is basically more array-based, so you can do the vector instructions in your processor, and functional style, where he writes C++ that is Haskell but spelled different. Like this style in C++ is very, very much like Haskell, and they're all in the same programming language because C++ is just bring them, we'll add that. Yeah, we'll add that to the language too. Everything can be added to the language. So you can write very weird, something that I did not think would be called C++, but there you go. I'll post that. I'll remember to post that in Piazza. I have faith in myself. So, my God, I've come in right at the right time. How's everybody doing? Any questions here? Okay, so if you liked this class, probably compilers, compilers might be relevant to you where you actually, build a thing. We do, in theory, have a functional programming course at the 4th year. I think it is effectively not taught anymore since Warren Burton was the one that taught it and he retired. Look for things that Rob Cameron is doing. He does his heart is down this path as well. I don't know what 383 usually covers. This is my version. This is what I usually do. Toby does recognizably the same course, but we certainly have different opinions on style and what we want to do. So I don't know. You got a quiz on Thursday. Any more questions as we're coming in towards 12:30 here, and I probably should stop. Hey, we have power again. 6 minutes ago. Oh no, 54 minutes ago my wife texted. So I could have actually, with a whole lot of stress, started only slightly late. Okay, so project complexity. Yeah, so I guess the things that you guys have left to do in the course, really, I'm going to assume you're done assignment 3, perhaps optimistically, but you have the quiz and you got the project. So I would guess that quite rightly more of your mind share is going towards the project right now than the quiz. I mean, the quiz does happen on Thursday whether you like it or not, but yeah, so for the project it is very hard for me to say anything about complexity. I think if you want, we can if you want to ask in Piazza, I guess, say, I've done this, what do you think? It's so hard because I'm trying to be very open-ended so you can do whatever you want as long as it's interesting to you, but that also leaves it so that I can't really say very much that's meaningful about difficulty. I think if you, we're definitely not going to count lines of code. I think thousands is probably a very big statement that I've made there. If you have done something interesting and you've used the 3 languages and 2 different communication methods and you've done something that's kind of cool in between, I think you have a reasonable project. I have said in the project description, I will point out some, I've tried to give some idea of the marking scheme here. So these things at the end are the hard ones, right? You can all check the boxes on I've done something. We're not going to be too harsh on judging the problem. You're obviously in this artificial situation where a project of the complexity that you're creating usually would not use 3 languages. I'm making you do something a little weird. You can use 3 languages. You can use 2 methods to talk. There is this much more ephemeral marking criteria, which is kind of, is it interesting? Is it good? And yeah, I don't think there's anything I can say that that can quantify that, sadly. Right. Distributed rate. Distributed system rate marcher. I know some of those words. Anyway, if you cite, I don't care how, basically for citations, I don't care how, just do it. If there's somewhere a comment that says this is from here, then that's fine. Yeah, I don't know how to pronounce Eosfin. Yeah, as long as you're writing a translation system between those natural languages in 3 different programming languages, you're cool. So yeah, anything else? So certainly will be available by Piazza. I don't remember when your project is due, if I'm perfectly honest. Whenever it's due, it's due then. It's very, I'm really not going to want to push it back, just because we do need time. The TAs have a completely non-trivial task to mark the thing. So they need some time for that. Probably not going to slip that deadline. It's apparently due Friday, December 11th, which is a week and a half from now. Do I know how I'm assigning letter grades? No. Well, I mean, I do, in the sense that what I'm going to do is take the letter grade cutoffs from last semester, look at the histogram, see how it looks, sort people by percent, and kind of see how the letter grades fall out, and try to give letter grades that I think are reasonable. So if you think that means I'm curving the course, then I am. If you think that doesn't mean curving, then I'm not. Oh yeah, Ethan, that's a good point. I didn't actually say that. But yeah, the same rule for code correctness on the quiz. I don't expect that you have necessarily compiled it and run it. I expect that it is conceptually correct. And if it's close enough to real Go code that it fools the TAs, then it's correct, roughly speaking. I guess I could. I don't know. Anything else? I feel like I've used my hour. I'm just impressed that it turns out I can fit a live streaming setup in a backpack. You need 2 displays though. Doing it from a laptop in a coffee shop would have sucked. Because of course I have the display that you can see and the one with the YouTube chat and everything that you can't see. You can bring a second display to a coffee shop, right? That's fine. So yeah, any other questions before we finish up? How do you feel about the background? Like, I have a fairly plain background at home. This is a little busier. It looks more academic. I could just take a picture of it and print it as a poster. I don't want it anyway. I'm going to take the relative silence in the chat to mean that we're probably fairly good here by way of questions. I'm going to put every piece of second tier audio video electronics that I have back in the backpack and go home. Yeah, I'm happy to say, if you have questions, I'm happy to hang out for the second hour. Don't get me wrong, but I also don't want to just sit here like an idiot watching the chat. Matches my clay. Okay, sure. Maybe I just need a better background at home. I could green screen it or something. It is a little disorganized, Josh. That is the fundamental problem. That, like, I wonder what the average, like, if there's a histogram of like, when did I last touch the book between like today and when I moved into this office, I bet a lot of the histogram is over on that moved into the office side. How to donate? I don't know. Do I have super chats? I have no idea. If there's a super chat, don't do that. Give your money to somebody who needs it. Yeah, like, but again, like, when did I last touch the LaTeX book? I don't. It's so much faster to Google something than to turn around and grab the book. I never do that. Cool. Thanks, long username. Hopefully, things went well. Hopefully the online learning was reasonable. Like, I know some of you are thriving and some of you friggin' hate it. I'm on the fence. Mostly I like it, but definitely this semester has dragged a little bit. I do have, and I've said this in a couple of contexts, but I definitely am going to be asking, I'll be sending out a survey that is basically, okay, let's say I'm teaching this course like a year from now and we're all back on campus and all vaccinated. What I want to keep the YouTube. I want to do tests in person. I want to keep the YouTube lectures. Are people going to feel like they're getting, ripped off by having to just watch the video or whatever? Because of course I can give the lecture, but you can't talk to your classmates the same way, right now, because you're sitting at home. It's not as good that way, but anyway. I have taught proper distance ed, like Compute 165 was distance ed, and it's not awesome. Like, fully distance ed. Look, Ethan, I have been like most spoken phrases of 2020. You're on mute and you need to buy a better microphone. Don't get me wrong. Like, yeah, I've tried. A bit of a hot button for me. Am I going to keep the semester playlist up? That's a good question. So I am probably going to. So I had a playlist from the summer semester, which I have hidden all those. Like I made all those videos unlisted just to prevent confusion. So you guys weren't seeing like old videos and new videos mixed up in some recommendation algorithm. But probably I'll keep these videos. Frankly, I'll probably keep these videos up until there is some reason to unlist them, which would probably be I'm teaching this course again. Did we all see Justin Trudeau telling some reporter that they're on mute? Like he's standing at the podium and obviously just looking at a laptop, and some reporter's asking a question. And he's like, "Dude, you're muted." So at least we're all getting it from our friends and family, and not from the Prime Minister. You could see the old videos. You could see the old playlist, but the old videos themselves should have been unlisted. So unlisted is if you can find a URL to it, you can get the video, but really? Whatever. Anyway, you figured it out. People didn't seem too horribly confused by whatever videos are on my channel. Did anybody use the searchable YouTube subtitles? Like, is it worth keeping that up? Do people actually type like monad into the search thing to find that spot in the lecture? It was fun. Like I very much enjoyed putting it together, but whether I need to keeping it running is a chore. Okay, so all right. So 3/4 of you used it. All right, fair enough. I don't know. So yeah, no final exam in this course. Yeah, do the project and you're done. I'll say a few things in Piazza probably, like about just finishing up the project, a few last minute things to just make sure you do this and this and this, but otherwise, I think I'm probably going to end there again, unless anybody is frantically typing a question, in which case type faster. Yeah, I'm going to stop there. Yeah, I'm glad people did on average seem to enjoy the course. Of course, there's a little bit of, I taught the course during the summer, so I had some idea what was going to happen, but different thing, and of course it'll be a whole different thing for the spring as well. I don't know what the vibe check is, long username. Anyway, so yeah, I'm gonna stop there. If you've got questions in Piazza, otherwise, good luck finishing up the project. Good luck in your other courses, whatever's going on there, and yeah. Hopefully everything finishes up for your semester. Have a good break and see you in January or whatever. Bye, everybody.